So here we've got a voltage divider circuit. A voltage divider is constructed from a 12-volt battery and two 20-ohm resistors as shown. Calculate the output voltage, V out, of the circuit. So what we want to work out, now when we draw a circuit like this, we could just about draw it like that. Okay? So we are just measuring the voltage across that R2 resistor. That's our output. Okay? So we've done this before. We've calculated voltage across resistors before, so we can do this. So our total resistance, what is it? 40. Just add them together. 40 ohms. So our current voltage is equal to IR, so current is equal to V on R. Remember I told you when I first showed you Ohm's law how much you'd be using it? I wasn't kidding. All right. So voltage is 12 over resistance is 40. So our current is then 0.3 amps. Okay, so we have our current of 0.3 amps. Now, it's a series circuit, so our current is the same everywhere, and so this becomes easy now. To work out V out is just going to be equal to IR. I is the current in our circuit, and R is the resistance of R2. Okay, so our voltage out is just IR2. So I is 0.3, R2 is 20, so that'll be 6 volts. Okay, so we start with a 12-volt battery, and just by putting it through a voltage divider circuit, we then have a 6-volt power supply. So we've effectively reduced the voltage. Okay, does this pass the common sense test?
Yes.
Yeah, why? Because it's half. We have two identical resistors here, so we would assume that each one uses the same amount of voltage. We start with 12 volts, so you'd think that each one of those would use 6 volts. Yep, absolutely. Passes the common sense test. So that's how